So talking about epoxides, epoxides are three-membered ring with an oxygen in it. They're pretty reactive. They're in a lot of ring strain. And we're going to talk about them. There are two sets of reactions and how we can be regioselective with these epoxides. So this is an unsymmetrical epoxide. So if we called it 1, 2, 3, 1, 2, 3, we can easily see that carbon 1 and 2 are different in these cases. Carbon 2 is more substituted. We could also add in another layer here and add in some stereochemistry. Right, if we think about epoxides, there's a little bit of stereochemistry. We've seen these before. We actually learned how to make these before. They come from the reaction of alkenes with a peroxy acid. So two different conditions. We're going to get two different products. I'll write the products out. So now I've drawn the products out, and what you can see here is, in the first case, the nucleophile, the new thing you're adding ends up on carbon 1, the less substituted carbon, and in the second conditions, it ends up on carbon 2. We consider these basic conditions. So the first one is considered basic conditions. This is called acidic conditions, which is really just a way of thinking about charges. So when we say basic, we really mean, at least in the first step, overall we have a negative charge or a really strong nucleophile. So we have really strong nucleophiles. So this is a Grignard. So this is really like having a carbon. This carbon right here has a negative charge. So we consider this basic conditions. And under basic conditions, the most important thing we think about are sterics. So we want to have our nucleophile, a really reactive nucleophile, go for the least sterically hindered position, when that would be carbon 1, the less substituted. So under basic conditions with these really strong nucleophiles, we do an SN2 addition, right, like an SN2 add. And of course it comes from the back side. Notice it's going for sigma star. The O minus there. It's almost making essentially a tetrahedral intermediate, 3 and 1. Right? If a tetrahedral intermediate, we ask ourselves, is there any other good leaving groups at this point? And I would guess we would all say no. Right? So there's nothing, H and carbon are not good leaving groups. So then we move on to the second step. And this is where it gets hard. So this is where people usually get confused. So the first step is basic conditions. Has an overall negative, has a negatively charged, really good nucleophile. Right? The second step is the workup. That's when we add the acid. These two steps do not mix. Right? Until we're done with this, we don't worry about adding this. And a lot of times this will be in excess. So the next step then, so we have this thing. We know we can't add any more Grignards. We don't have any more electrophiles here. So we go to the second step, which is protonation. There, and that gives us this. That's that protonation step. That gives us the product. Transaddition, basic conditions, strong nucleophile first step, right? We make a alcohol here in this reaction. So now why we call this acidic conditions, maybe it's a little easier to see. If you see H+, if you see HCl, HBr, HI, sulfuric, those kind of things, those are acidic conditions. And a lot of times the nucleophile ends up being the solvent. You've seen this before when we did Br2. This looks very similar to Br2, and it's actually the first step is going to be very similar to the Br2 reaction. So let's kind of focus on this. So each step of the way, what's my nucleophile, what's my electrophile? In the first step here, if you have H+, that's the best. That's a really, really good electrophile. So that means your epoxide has to be the nucleophile. A little different than before. So this case, the first step is actually going to be protonation. And you're going to protonate the epoxide. So there's the epoxide has been protonated. Now why did this makes this epoxide actually more reactive, right? This is my nucleophile, this is my electrophile. So it's different than the first step where the epoxide acts as an electrophile first. So in this case, we've now protonated our epoxide. Now the question is, which carbon are we going to react with, carbon 1 or carbon 2? We're actually going to react with carbon 2 because that can be the most delta plus. Now it's like carbocations. You think about, in acidic conditions, you think about carbocation rules. In carbocation rules, the more substituted, the more stable. So that's going to be the more delta plus site. So in acidic conditions, and a lot of times, again, like it's the solvent that reacts. We're going to go for the more substituted carbon. So that's that SN2 kind of addition step. All right, so now what do we have from this? So we had acidic condition. So I should write that in there. The first step was a protonation. All right, we're making the epoxide more reactive. The epoxide lone pair reaction is a nucleophile. H plus is the electrophile. Now the next step, carbon 2 becomes the best electrophile, kind of those carbocation kind of conditions, even though we don't make a carbocation. Solvent comes in and reacts, opens up SN2 addition, this trans addition. We're not done yet though, and this will always be written in. A lot of times these are acid catalyzed, so that means we're not done until we've regenerated catalyst. Regenerate the catalyst. So we'd say this is a deprotonation. And that gets us to that. Big take-home messages. Acidic basic conditions. How do you be able to recognize these different things? Acidic conditions, you'll see H+, HCl, HPR, HI, something like that. You will not see very good nucleophiles. By good nucleophiles, I mean things with negative charges. Carbanions, right? Grignard organolithiums, you've seen hydrides, you've seen acetylized, deprotonated sp hybridized atoms, things with negative charges, right? Carbons with negative charges, hydrogen with negative charge. Those will be, right, in basic conditions. So those will be more found up there, right? Those first step ones, right? Even though the second step has acid, that's not how we talk about it. It's all about the first step, different steps along the way.